So on to question 28. Now we notice here it's a similar sort of thing. They're telling me the area. This is something that I'd usually have to work out for a question. So if they're telling me the area, we're going to try and work it out ourselves. And then from there, we equate it to the 80 pi they've given me. And we should be able to manipulate that to find any other unknowns. Now when you have a look at the equation that the volume's given in, it has the x. So we definitely want the x. But what it doesn't have is an idea of the length of this whole cylinder. Now it does tell us in the question this is a very tight fitting lid. Now what we can assume from there is that the radius is the same. The lid doesn't need to be wider than the tin, which isn't necessarily what would be there in real life, but we can assume that from the question. The thing is then, what do I need for surface area? Well, I need to know the area of the circle, but I also need to know the combined length of the whole cylinder. So if you imagine you pop this on top but didn't push it to overlap it, we just like rested it on top, then we would then have a combined area, and if we just maybe call this h for the height, this would be then h plus 1. So this is what we're going to have to work on, and effectively I'm going to try and find something in terms of this h, because then if I can find an equation of h in terms of x, then I can use that value of h in my further calculations. So let's have a look to see how we start. How would I find the area of a cylinder? Well, the first thing in a cylinder is I've got two circles, so that's going to be just pi times x squared, and I've got two of those, so times by 2. And then I'd be adding the area of this enclosed cylinder. Now the area of the enclosed cylinder, if I was able to cut that open and spread it out again, we'd actually end up with a rectangle. The rectangle would have a length of h plus 1, so the combined length of the height that we don't know here and the 1, and then the other part of it would then actually be equal to the circumference of that circle. If you imagine if I slice this down and open it back out, it'd be equal to the circumference. So that would be then 2 pi x. So if we start working from here, and now we can say that the area is 80 pi, to give me 2 pi x squared, and then what have I got here? Well, I've got plus 2 pi xh, and just 2 pi x when I multiply out that bracket. And what you're now going to do is have a go at finding the value of h. Now, when we go through and simplify this, you should really be able to cancel out all of these pi terms here. So we'll see if we're able to do that. And basically, we want a value for h. Once I've got that value for h, we're then going to say, well, volume of a cylinder is the area times by the combined length. The combined length would be the h plus 1. The area would be pi r squared or pi x squared in this case. But remember, we are going to use the value of h that we find here. So make h the subject of this equation, and we're then going to use that in this calculation. So pi x squared times by h plus 1, but we're going to use our substituted value from this into that h. The algebraic manipulation is a little tougher on this question. That's why it's 5 marks. But you should be good for it. Our skills up to this point should be good for it. So good luck with 28. And let's see if we can get further into it than a few of you have now. Just looking further down the question, use differentiation. So we know how to differentiate. Prove the value of x gives a maximum value for v. So that's finding the second derivative. And then proving at that value of x that, well, if it's going to be a maximum, we'd want to prove that the second derivative was negative. Find the maximum value of v, so take your x and put it into the calculation for v that you get given in part A. And percentages, I hope that we could do on our own. Okay, good luck with that one.